Okay, let's look at a hyperbolic function. So here's an example of what a hyperbolic function might look like when they give it to you in the book. And there are different ways of graphing it. I'm going to try to graph it from a perspective of a product. One of the things that hopefully you've learned is that a hyperbolic function occurs when two quantities multiply to the same number. So the best thing to do here probably would be to see if I can rewrite it so that I can have a product. So let's start by adding 3 on both sides. So I have y plus 3 and then 1 over x. Think of this as a fraction by just placing it over 1, and then you can make it a factor like this, and then your cross product here is going to create that product that I just mentioned. So this function is the result of x times y plus 3 always equaling 1. Okay, I think that helps. Sometimes it helps us find numbers. In this case, maybe not so. But where it does help is to understand why do we have asymptotes. Okay, so the hyperbolic function is going to have asymptotes because there are a couple of values, in this case 2 values, that you just cannot use. For example, if I made x equal to 0, is there any number that we can think of for y that would make 0 times this quantity equal to 1? Well, hopefully you agree with me that that's impossible. So x is not allowed to be 0. Well, that also means then that y plus 3 cannot equal 0. Well, that means that y can equal a negative 3. Okay, so basically solving there. And that right here tells us that we have an asymptote at x is 0, and since x is 0 it would be a vertical line, so we get a vertical asymptote at x is 0, and the horizontal asymptote here occurs at y equals a negative 3. Okay, so although you can see it in here, because you can see here that you can't have, x can't be 0 here because you can't divide by 0, so that's easy to spot. And if you think of transformations, you can see that this is a shift down of 3, so that's a shift down of 3. So if the normal asymptote would be on the x-axis, then now it became at y is a negative 3. So you can certainly see the asymptotes in this equation as well. It doesn't really explain why it's an asymptote. I think it does it much better if you look at it this way. Okay, so took a little longer, but now you hopefully have an understanding of why that is an asymptote. So let's graph this thing now. Well, basically, hyperbolics are graphed by graphing your asymptotes and then finding some dots to fill in so that you can get a shape. Okay, so that's the line x is 0, right? It's actually the y-axis. And the line y is a negative 3 would run right through a negative 3. So there's my second asymptote. And then I just need to find some values. So let's check what happens at 1. Let's check what happens at a negative 1. And then we'll go on from there. So big 1. And that means you get 1 over 1, which is 1 minus 3. So that's a negative 2. Let's use a negative 1. 1 divided by negative 1 minus 3. Well, that's a negative 1. And a negative 1 minus 3 is a negative 4. That might not be enough. So let me try a couple more, see if there's anything else that I can get. So if I use 2, you sort of see the problem here with hyperbolic functions, and that is that we end up with fractions, a lot of fractions with these. I don't know what a half minus 3 is, but 3 minus a half would be 2.5. So if I just make that negative, then that should probably work. And you could do the same thing at a negative 2. At a negative 2, you would have 1 divided by negative 2 minus 3. So you're at a negative a half minus 3 is a negative 3.5. So you see you get more fractions. So they don't help too much. Okay? They do confirm something for me, but we'll see that here in just a second. So at 1, I'm going to graph a dot at a negative 2. Okay, the dot that I found at 2 pushes me a little bit closer to the asymptote because it should be at a negative 2.5. So that should be here. So you can see that that's what we want. The asymptote is the line that this graph is going to approach. Well, the same thing happens over here. I don't really need to find more dots to sort of tell you that this is what's going to happen. And you'll have to excuse my poor drawing there. I have a hard time drawing this, but that's the kind of shape we get on that side. And the same thing happens on the left side of 0. So at a negative 1, we get a dot at a negative 4. If I had wanted to use the dot at a negative 2, it would be at a -3.5, which again pushes me a little closer to the asymptote. But you know, we already know that that's going to happen. That's what the asymptote sort of tells us, is that this graph is going to approach those two values. This is going to approach here, and it's going to approach there. And then that's the overall graph. And that sort of gives you background as to why we have asymptotes and where they're located. So I hope it helps.